Start. Okay. Before we start, Jennifer I want to take just a few minutes to talk about SPWLA. I'm Mazen Hilali. I'm the chairperson of SPWLA Iraq. I like to welcome all the attendees for this webinar. This is our sixth webinar in Iraq. It is like it's our monthly practice to do one webinar per month. I will talk about our webinar in a while, okay? And to go ahead, I will give the mic for Jennifer to speak.
Thank you, Masin. I'll prepare some slides. It's only 3 to 4 slides. Can you guys see my screen? Can you guys see my screen?
Yes.
Yes, okay.
Yes.
All right, okay. Thank you and hello, everyone. My name is Jennifer Duarte and I'm the Regional Director of SPWLA for Middle East and Africa region. Thank you to SPWLA Iraq for inviting me to give a brief introduction about SPWLA membership benefits to the members in Iraq. I'm glad to see the chapter has been very active since its inauguration, almost, I think it's a year back since you guys started. So I'm very pleased to see how active you guys are and all the events that you guys have planned so far. Now, for the next 3 to 4 minutes, I'd like to tell you about the SPWLA as a society and the benefits that are included for actually being a member. I don't want to take too much time away from the great technical presentation that is lined up for today. So more or less, it will take 3 to 4 minutes before I hand it over. Now, as a society, SPWLA is a nonprofit corporation founded in Oklahoma. I think it was back in 1959, long time ago. And we actually have a business office where the headquarters are in Houston, in Texas. Now, here you can see the people that are sitting in the international board. Our 65th president this year is Jennifer Marker, and the president-elect is Julian, who will be president next year. Now, the board comes and go every 1 or 2 years, but you always will have the business people at the business office. The business office people that are Sharon and Stephanie, who are in these pictures as well. They're always going to be there. Now, when it comes to the regions and local chapters, we have 6 different regional directors helping all the local chapters in the regions. Now, in my case, I work as a liaison between the local chapters in the Middle East and Africa and the Board of International Boards, in addition to actually offer assistance to the local chapters in the region. There's also a regional director in Latin America, North America, Europe, and Asia Pacific, as you can see here from these slides. Now, as an education organization, our goals are to keep providing educational programs to empower individuals with knowledge, skills, and values. We also provide adequate funding and support for qualified students to ensure equal access to education. Now, being a global organization, we address global challenges that the local chapters face. We try to promote collaboration and cooperations and engage with our special interest groups, which I will actually mention later in the upcoming slides. Now, our focus as a society is the hydrocarbon industry. However, it is in our future to promote alternatives to surface and the energy transition. So this relates to the advancements of the science of petrophysics and formation evaluation in non-traditional and new environments. So in particular, the low carbon industries such as carbon capture, utilization and storage, geothermal, nuclear waste, storage, and non-hydrocarbon extractive industry. Now, as a society that embraces diversity and inclusivity, our goal is actually to create an environment where all individuals are respected and provide equal opportunities for growth, participation, engagement, student, and contribution to actually the society as a whole. Now, a little bit on the benefits that the SPW membership brings. So as a member, you have access to our monthly webinars. They're actually held at a convenient time. So we have both the Eastern and Western Hemisphere. We also publish the Petrophysical Journal 6 times a year. So members are actually entitled to read the online version or download it if you want. The SPWA Today magazine is also bi-monthly, and this is a way for us to actually be in communication with the members. So there are interesting articles related to petrophysics, formation evaluation, and then also the board members columns that you guys can read chapters, news, and much more, as well as the SIG groups. Now we have 39 international chapters worldwide, of which 8 are Middle East and Africa chapters base, and we recently just finished forming another one in the Middle East. So that's the SPWLA Algeria. Apart from the for the professional chapters, we also have student chapters worldwide. At the moment, there are 21. So you can see there's a lot of benefits and activities going on. We have topical conference, regional conference, local chapter activities worldwide. When it comes to the benefits or members, again, as I mentioned, you get access to the publications. Member can either read online or download PDF copies of the journals, the newsletter. Members have also access to in the website of SPWLA, we have access to the curve and tilt mnemonics database, which you as a member can go log in and then download them if you want. The last time I checked, I think we have around 120,000 curve mnemonic captures that were on the database. So members can also watch previously recorded webinars and acquire papers, SPWA papers at a discount. And then also you get, if you are participating into the annual symposium, which is once a year, then you get to have a discount to all the events, including, the in-person and online training and topical conference. And finally, privileges also include the ability to vote in elections and serve on both local chapters and international boards of directors as well. We have 2 levels of professional membership. So there's the group 1 and group 2. The group that a member belongs to is designated by the country where you are based. So we have similar 2-level structure within the students membership as well. And if you would like to sponsor any of the student chapters or any student membership, you could get in touch with the SPWLA for this. And then finally, we have chapters affiliated who only receive local chapter benefits. Now, on this one, there are several ways that the SPWA community can be engaged with the membership. So the first is actually through our website, actually both of our websites. So there's 2, spwla.org and SPWA today, which is mostly when it comes to submitting the abstract submission to various events and act as a dedicated annual symposium website. We also publish a bi-monthly news magazine called SPWLA Today. And of course, we publish the Petrophysics Journal 6 times a year. So as you can see, there's a lot of ways that we could also communicate with the members. Now, a recent addition to the SPW benefits is the YouTube channel. So this is a collection of all the webinars, local chapters presentation, and the more to know webinar advertising. So if you want to subscribe, here's the link that I put it down on the bottom on the left, where you could have access to. You first need to subscribe and then have access to it. Now, when it comes to the special interest group, SIGs, which how we call it, we currently have 12 special groups. The 2 most recent added are the alternative subsurface and energy transition, or we call it ASET, and the borehole imaging, SIGs. Both where they held workshops at the annual symposium and actually are developed a strong following throughout the past, for the past month. All of these SIGs are looking to expand their global footprint. So if you have interest on the nuclear or NMR petrophysics or formation testing on the borehole imaging or the acoustics or even the data-driven analytics, then you could just consider joining any of this special interest group if you want. More details can actually be found in our website. As you can see, there is so much you can do. You could get involved with your local chapters. So SSGs are moving more and more online. So you could sign up to a SSG group. Maybe think about writing an abstract for the annual symposium. In fact, this year's symposium was in Texas, and next year will be in Brazil, and the following will be in Dubai. You could also join a commit. We have lots of them. You could also contact the BPO publication if you would like to become a technical editor for petrophysics. If you would like to give a webinar or conduct a training course, you could also contact our BPO of education. If you are active in social media, maybe try to join our social media team if you want. And lastly, SPWA only exists because of the volunteers, right? We all do this as a because we like to contribute either with the technical knowledge, demonstrate commitment and responsibility. So this is what SPWLA does, right? And finally, just a reminder that please know that the 2024 SPWLA symposium will be hosted in the Brazil chapter, as I mentioned before, and it will be held in Rio de Janeiro. And the upcoming one in 2025 will be in Dubai. And then, yeah, with that, I finished what I have prepared to show you guys. Sorry, I didn't want to take too much time of your time on the technical side.
Thank you, Jennifer. That was really a great presentation. It summarized a lot, okay, in regard to SPWLA value added for its member and to support petrophysical community. Thank you so much. I will just, if you, Dr. Mohammed, want to say something before we go ahead? Okay.
Yes, thank you, Mr. Mazen. As a SPWLA Iraq chapter team, I would like to welcome to SPWLA Regional Director, Middle East Africa, Ms. Jennifer Dreit, and by collaborating with Mr. Mazen, or the President of SPWLA Iraq chapter. My name is Muhammad Jawad. I am the Senior Faculty member in the University of Iraq. At the College of Engineering, Department of Petroleum Engineering. I have a PhD in Petroleum Engineering. I'm the Vice President of Technology. This year, we planned to make some scientific lectures in our SPWLA chapter of Iraq. So today, this is the sixth one. Society of Petrophysicists and Well Log Analysis Iraq chapter would like to introduce the webinar casing inspection in high temperature wells by Scientific Drilling Company. It will be presented by Mr. Samir Mostafa. Welcome to Mr. Samir Mostafa too, and all of ODs in our chapter. Thank you very much for your coming and listening to us. Thank you.
Thank you, Dr. Mohammed. Just in 1 minute, okay, just I will show our audience our current and next webinar. Okay, if somebody want to join upcoming events and to introduce Mr. Samir Mostafa. So I hope my screen, everybody can see my screen. Hello?
Yes, we can see.
Oh, okay. So welcome all again. Okay, this is our sixth webinar. It will be integrated in high temperature well, presented by Scientific Drilling Company. Mr. Samir Mostafa is the regional manager for Scientific Drilling. He holds bachelor and master degree in petroleum engineering as well. He's based in Saudi, and he have been in the business of cased hole logging since long time. This is our sixth webinar. We have been accomplished 5 of them. This is the sixth one. Next month we will have a webinar with GeoActive company in regard to cement evaluation by interactive petrophysical software. This will be under the support of Ms. Jennifer as well, team. And for the people that attend our sixth webinar, they will get a special certificate, which is be a super learner certificate people. And for the people that I saw many people that have been joined Iraq chapter, but they put other country, it will be appreciated just to change your location to Iraq. Okay, thank you so much. And without further ado, I will leave the mic to Mr. Samir.
All right. Thank you guys for the introduction. I have some slides to share. So just go through to the topic. I'll switch off my camera so you can see my my slides. Just feel free to ask any questions. I don't know, like how's the protocol there? If you'd like to raise hand or open your microphone and ask questions, that's okay.
You can. Everybody can ask during the meeting. If you can raise hand, it will be better. Okay. Even we prefer to ask after the webinar, so we don't cut. But if somebody want to jump and ask it, it's okay, because it's mostly similar to our workshop, small workshop.
All right. Okay. Thank you, Mr. Mazen. So yeah, that's my slides. I hope you can see my screen. As we have a policy in SDI, it's okay to start the meetings with safety moment. So I have a quick safety moment for today, with all the news in social media around us and the negative vibes. Just take care of your mental health. Try to always not to expose yourself to a lot of stressing news. Just try to get out of that and read books and or do some any sport you like and so on. So this is will free your stress from your daily routine. So that's my safety moment for today. For the agenda, I have introduction, why we are having this presentation, why it is important to have a high temperature, high pressure tools for our industry, how this is aligned with the world energy outlook, and how we are matching the HT challenge with the global energy trends, and how do we define high pressure, high temperature wells? What is the definition of high pressure, high temperature wells? And then we will go through the technology, the corrosion technology as a general, just a quick background overview, and then the multi-finger caliper in specific. And then we will discuss two cases, one from North America and the other one is from the Middle East. They are both possessing high temperature downhole environment above 150 degrees C. And then the background and conclusion, if we have time, the floor will be open for questions. So I thought to let me remove this small. Okay, so I thought to have this slide here so we can know that why we need high temperature and high pressure tools for our industry more than ever. So as you can see here on this chart, this is the global gas consumption since 1998 till 2022. The source is Statista website, and we can see like a growing trend on the gas resources. So the world is requiring more gas resources because it's a clean source of energy, and it aligns very well with the global objective of having like a zero emission, or at least to reduce the carbon emission of our industry. So most of countries are trying to shift their domestic energy to have natural gas. So this is, you can have access to the full report from BB Energy Outlook in 2019 till 2023. So as the world needs more gas resources, more natural gas and LNG, most of the gas resources are actually linked to high pressure, high temperature. So how do we define that this well is high pressure, or it is a high temperature? So the classification or the term itself, it's high pressure, high temperature, may be applied on the wells that have only high pressure or the wells that have high temperature, or both of them. So there is one interesting study that has been done by SLB back in 2012, that out of 100,000 wells drilled in this year, 1.5% only were high pressure, high temperature. So this is a very small number. It's a very relatively small number, but those wells are very high profile hydrocarbon targets. They are possessing or storing a very high profile hydrocarbon targets. So the well can be a high pressure, as we can see here, if the or due to the pore pressure. That's pore pressure is the fluids that within the pores or in the formation rocks. So the pore pressure increase with the depth because the formation must support. So the pore pressure versus the depth can change rapidly due to the geologic features and variable overburden forces that make this interval as a high pressure. So this is how we define the word high pressure. In the high temperature, the story is a little bit different. So as mainly depend on the earth geothermal gradient, as we all know. So we have an average geothermal gradient of 1.4 degree per 100 feet or 2.55 degrees C per 100 meter. Considering this gradient, so we will reach above 350 degree F, and you will know why exactly 350 degree F in just 6,000 meter. And this is now like most of the national IOCs or the national oil companies or IOCs are drilling that deep. So that means that the number of high temperature wells are increasing rapidly. So this is just to define the what is meant by high pressure and high temperature in terms of geologic features and downhole classification. So in the next slide, as we can see here, this is classification from SLB, the defining series. All the copyrights go to SLB. So we are defining it like the if the well has a bottom hole temperature above 300 degree F or 150 degree C, this is considered to be high pressure, high temperature well. If it is above 400 degree F, we are in the zone of ultra high pressure, high temperature. And I have seen this a lot in Oman, for example, some deeper formation like Amin formation, Khuf formation, where the operators are exploring deep gas zones. So we can see those ultra high temperature, and also the big abundance of those number of wells are lying in high pressure and high temperature. There is also some wells that above 260 degrees C in some parts of Australia and some parts of Asia Pac, and also the geothermal wells as well. So there's some wells in Asia Pac that where we are producing steam from the geothermal wells, and those are considered to be an extreme high pressure, high temperature well, where the bottom hole temperature is above 260 degree. So so the availability of inspection logs or video imaging and surveillance technology and electronics rated above 300 degree F is very limited, and this is for a reason. One, it's a commercial reason, because as I mentioned in the previous study, they are only 1.5 to 2-3% of the total number of wells drilled. So the oil field services companies are not considering developing a lot of high pressure, high temperature tools, because the number of wells are very limited, and also they are very challenging. The technology itself, it requires like a high maintenance and high repair cost because we are using different material for those equipment. So next slide. This is the technology available in the market. So once we increase the temperature, or when the bottom hole temperature increase, the limited technology offering is the bottom hole technology offering is very limited. It's expensive material, critical operations, and very fewer number of wells. So no, or not a lot of companies are willing to invest on develop those ultra high temperature, high pressure downhole equipment. Okay, so in terms of downhole casing inspection, this is a quick background overview just to remind you what is available in the market. So the casing inspection technologies, there is like 5 types, and you can review the cased hole book by James Smolin. It's a very good book. So we have the mechanical caliper, okay, which is a mechanical fingers that interacting with the internal surface of the tubular, either it's tubing or casing, and it's one of the most accurate direct measurement in our industry as of now. Despite it's a very old tool, very old technology, but still one of the most accurate downhole measurement, because it's very straightforward and it's a mechanical measurement. And we have the electromagnetic tools. This is electromagnetic pulse. It's in like electric current goes through a magnet. This magnet is producing a pulse, magnetic pulse, that magnetize the surrounding casing, and then there is multiple technologies that can measure these this response. As a time domain tool, we are measuring the decay of this magnetic pulse, and this decay will depend on how much metal we have. Is either it's a metal loss or a metal gain. So we can differentiate between the corrosion, internal corrosion, external corrosion, or we have a casing collar, tubing collar, and so on. And we have the acoustic devices. Acoustic devices is like acoustic waves that interact with the tubular, but we have to have a fluid in the wheel bore, so the sonic waves can travel through the fluid and interact with the different tubulars. Those tools have its advantage and disadvantage. Borehole video cameras. I have seen a lot of operators are using borehole video cameras now to just define, as you can see here, to define or to know qualitatively what integrity issues or corrosion issues that we are having downhole. And we have a casing potential profiles. I haven't seen much of technologies in the market, but it's like electrochemical physics. We have anode, cathode, and they are measuring the difference potential between those 2 points, and we can define if we have a scale deposition or a corrosion deposition, and we can define if there is an integrity issue in our wheel bore. So as our presentation is focusing on the multi-finger caliper, so I have a couple of slides to
Sorry, Samir.
yes.
Just a question regarding the last one. What you called
Yes.
it? Casing potential?
Casing potential profiles, yes.
So are there such wireline tool now, or it is just concept? Like, are there?
As far my knowledge, I haven't seen anyone is using it, but it's mentioned in one of the physical principles that can be defined the corrosion. So actually it's an electrochemical reaction. This is electromagnetic, and we are here using electrochemical interaction.
Okay,
But I haven't seen a lot of companies are using that.
using it.
Yeah.
Okay.
Yeah.
Okay.
Yeah.
Thanks.
Yeah. So a multi-finger caliper. So it's a very straightforward tool. I have done this diagram here to explain to you what is the principle of measurement. So this tip interacting with the internal surface of tubular. So this is the anatomy of the tool. So we have like carbide or a special material of the tip of the finger, and this is the finger which you see in the pictures. You can see here, this is the fingers. Okay, so this tip is interacting with the tubing or casing, and it can goes inside in this direction, or it can go outside in this direction. So this lateral movement is transforming to a linear movement, and this linear movement is moving the core. The core is a device integrated on a device called LVDT, linear variable displacement transformer, which is like changing this lateral or radial movement to a linear movement. And we have electric pulsation here, electric pulsation here that change the current, and then we can get the measurements. Those measurement from the analog goes to the digital, and from the computer processing unit inside the tool, and then we can get the reading. Okay, so this is the principle of the measurement of the multi-finger caliper. So the technology itself is lying here. So the LVDT, that's the know-how or the underlying magic of the multi-finger calipers. Before, like 20 or 30 years ago, there was a min and max multi-finger caliper. You can have two arms that can give you the minimum and maximum. Now the tool has been developed, and you can have 24 arm, 40 arm, 58 arm, 60 arm, depends on the manufacturer. The diameter of the tool is 1.85. That's for the ultra high temp, and the 1.75 for the normal temperature. The number of sensors is 24 arms. So we have 24 fingers. The measurement range is 1.8 and 7.2. This important thing when you are using a multi-finger caliper from your oil field services provider, always ask about the measurement range, because this will give you either high accuracy or low accuracy, or high resolution, low resolution, depends on the casing or the tubing that you are using in caliper on. The radial resolution range, that's from 0.185 inch to 0.5 inch horizontal resolution, and we have a horizontal accuracy as low as 0.01 of inch. And we can log with a speed of 30 feet per minute. That's 10 meter per minute, actually. So the tool itself is rated up to 10,000 psi, and the temperature rating is 220 degrees C. That's one of very few tools in the market, especially in the multi-finger caliber, that is rated up to 220 degree C. So this is enable the operator and the companies to inspect their downhole casing and tabulars in extreme temperature conditions without the need to cool down the well or pump like killing fluids or water and so on, because this thermal cycling is affecting the casing and tubing. That's why having a high pressure, high temperature multi-finger caliber tool can address multiple answers in challenging downhole conditions as high temperature conditions. So this is the how the tool looks like. So this is the assembly that we are deploying inside the tool. Just quick reminder, this is anatomy of one finger. This is how the tool itself looks like. So we are starting from the bottom to the top. So the bottom, we have a bull nose, we have a lower centralizers, and these are the fingers, and this is the electronic sections. Okay, and we have a motor here. This motor is controlling the fingers open and finger close. We have a CCL, casing collar locator. We have a upper centralizers and the knuckle joints. If you are deploying the tool in a deviated well and you don't want your tool to be hanged or to have a problem in high dog legs and high tortuosity, we have to add knuckle joints to make it much more flexible and give much more detachment to the assembly. So this tool is available on memory mode, and the cases that I'm going to show you, it's has been deployed on a slickline or coil tubing. But there are some oil field services manufacturer and provider, they are providing it also with wireline. So it can be deployed by a wireline that will give you a real-time data on the surface, or it can be deployed by slickline and coil tubing as a memory, which we record the tool downhole, and then we retrieve the data when we rig down. So you're probably asking like how you are controlling those fingers are open or closed. So the tool itself has a brain. So we are programming the tool on the surface, okay, and we are asking the tool to open the fingers after, let's say, 6 hours. So after exactly 6 hours, the fingers will open and you will start to look up. So one of the procedures of running the multi-finger caliber that you never look down. It's always looking up because the fingers will be open and then you are looking up. So if the fingers are open, you never look down. The good thing that it's a memory, so you don't have to call like a wireline unit tool, a wireline unit truck, 4 people crew and so on. Simple slick line unit can do the job. So this is one of the advantage, but one of the disadvantage that you will never know what is happening downhole unless you rig down the tool. So if everything comes as a trade-off, you get one thing and then the expense of the other things. So that's for the multi-finger caliber. So I have a couple of cases here. So the first case is from North America. It's a SAGD well, and if you're not familiar with the SAGD, it's a steam-assisted gravity drained well. So they are using this in Canada, and some operators now in the Middle East are using it as well. So they are drilling 2 wells, twinning 2 horizontal wells near to each other with a very close separation factor, and they are injecting steam in one of the wells, and the gravity will take the steam down This steam will heat the high API well, the high API oil. I cannot remember the high viscosity oil. Let me call it this way. So the high viscosity oil, and then this oil will flow from the other well, which is the producer. So the operator sought to evaluate the integrity of the completion without having to cool the well to the temperature below 150 degrees C. Why 50 degrees C? Because most of the tools available in the market are below 150 degrees C or 300 degree F. So the operator has to inject water or cool fluid to cool down the well. In this case, we don't have to, because we have a multi-finger caliper tool that rated up to 428 degree F. So a memory multi-finger caliper was deployed using a cold tubing, and the data were successfully obtained with a maximum temperature of 169 degree C. As we can see here, just to walk you through the this plot. So this is the depth track. This is the CCL track and inclination. As you can see here, the inclination, and those black curve is the CCL. And here in the second track, we have two curves. The temperature of the well, that's the red curve. This is the temperature of our well, and this purple curve is the internal temperature of our tool. So thanks to the flasking system and the heat shield system, that allows us to keep the internal component of the tool as low as possible, and we are able to log this well with 169 degree bottom hole temperature. So that's the plot for the temperature and the CCL.
Okay.
Yes.
Engineer, sorry. So for this SAJD well, I'm not really familiar with this one. It is a steam injector well, or it is like a well that's producing oil have steam completion to help oil production?
Okay, so it's a steam well. It's a steam injector well. Okay, so Mazen, they are drilling two wells, two laterals very near to each other, one above the other. Okay, the first lateral, which is above, is the steam injector, which is a horizontal well actually, and they are drilling another well below that horizontal injector is a producer, and you are injecting steam in the first well. So I can explain that here. Let me. I'm just trying to get the okay.
I believe there is a way to
Yes.
something.
Yeah. So that's like the injector, okay, and they are drilling another producer like this. Okay, so they are injecting steam like this here, okay, and this steam goes by gravity to the producer here, and then the oil, the high viscous oil from those fields will go from this producer. Okay, so there is some complex drilling challenges here. Actually, this separation factor, like it's very close, maybe like 3, 4, 5 meters, something like that. So so they are drilling these wells using technology called magnetic ranging. Okay. So they are using the interference, the magnetic interference from the existing producer to twin or drill another lateral very close to that producer, and then they inject steam from here. This steam will go and heat the surrounding formation and surrounding oil, and then the oil will be produced from the other producer and the other lateral here. So this is called SAGD. Yeah. So steam assisted gravity drainage. So they are
interesting.
Yes, they are very common in Canada, and surprisingly, I have seen one case that I have worked on just a few months ago in Oman. So now this operator is moving this technology to Oman for one of the thermal EOR fields in Oman, and we were lucky to work on the ranging for this project. So those wells actually are high pressure, high temperature, above 150 degree
Both
C.
well or only the steam injection well?
The steam injector, because you are keeping steam, like injecting steam. The producer is not extremely high, maybe 120, maybe 110, like below 150 degrees C.
Okay, thank you.
Mhm. Yeah. So here is the real thing. So if everyone likes the 3D plots, so this is the caliber data, and as we can see here, this figure includes the 2D log data in cross section and a 3D image, as we can see here, 3D image of the processed caliber data, and the caliber measurement of the LEP, the limited entry perforation. So the objective of the operator here is to check the quality of the limited entry perforation. That's one of the like completion that the operator is doing to make sure that they are injecting steam to the right intervals. So this is the limited entry perforation, and the operator would like to define those points here. So we can see from the 3D image that we are able to identify the limited entry perforation interval in extreme temperature condition. So this perforation was as small as 0.5 inch. That's really small, and the multi-finger caliber picked it, and in extreme temperature condition as well. Here is another 3D plot for enlarged diameter limited entry perforation. We can see that here, and the multi-finger caliber also were able to the multi-finger caliber was able to see that limited entry perforation as small as for 41 millimeter. So that's the cross section. So we were able to define the limited entry perforation. How can this benefit you? Okay, despite that you don't have a SAGD well, we can run the multi-finger caliber to check the perforation quality. I have done some cases combining gamma ray, CCL, multi-finger caliber, and we locked a perforation interval. We make sure that all the perforations were fully open, and we're penetrating the casing. And by having this data correlated with the cased hole gamma ray and then open hole gamma ray, we will make sure that we are placing the perforation exactly to the bay zone. So this is one of the benefits that we can do with the multi-finger caliber in the high pressure, high temperature wells that you probably have in the Middle East. It's not necessary to have it in a steam well. You can deploy it in a gas well, deep wells, unconventional tight gas reservoirs that can tell you the condition of the casing, and also can help you to assess the perforation quality and the perforation placement as well. So this is the first case. The second case is a vertical steam injector from the Middle East. So we have here the plot. So the first track is the depth, second track is the CCL, and the last track on the right is the temperature logs. So the red curve is the bottom hole temperature from measurement from the tool, and this purple curve is the internal temperature of the tool. Why internal temperature is important to have? Internal temperature, we are measuring internal temperature because of the internal component of the electronics and the boards and lithium batteries and so on are all rated up to 165 degrees C. So we need to isolate or insulate the external temperature of the well bore from reaching or heating up the internal component of the tool. So it's the science here of having high temperature or high pressure tools. It comes in two things: the material that you are using, and the boards that it should be rated as high as 165 degrees C, and the flasking system that slow down the heating up of the tool from the external temperature of the well bore. So we can see here this is a steam injector from the Middle East. So the operator here was suspecting deformation of the downhole tubulars of this vertical steam injector. The steam was injected 24/7 over like so many years. So by injecting 290 degrees C of steam continuously with no stop, in this well, that will subject the casing and the tubing to a great heat stress, and hence you will have like a deformation in the casing and will subject the entire wellbore integrity to a critical risk of departing casing or a buckling or shearing, or as we will see on the next few slides. So the operator, like when they are planning to run multi-finger caliper on those wells using a standard temperature tools, they have to call like a pumping unit or a hoist and start to pump fluid till they reduce the bottom hole temperature of this well below 150 degrees C. Why? Because most of the tools in the market, or like the majority of them, are rated up to 150 degrees C. So they have to cool down the well, and this will affect the reservoir, will affect the integrity of the well bore, and then they are able to run the multi-finger caliper. In our case, we just shut in the well for like 2-3 days, 4 days maximum, till the bottom hole temperature is below 428 degree F, which is the temperature rating of the multi-finger caliper, 225 degrees C, and we were able to run the multi-finger caliper in this steam injection well. So here,
Samir,
yes.
just before you go ahead, there is a quick question on the chat. Can you check them? If you can answer them quickly, if you like to answer them.
All right, I'll
on the chat section.
Okay. Okay, for Mr. Randu, sorry if I get the name wrong. The inspection technology, each inspection technology actually is different. So if you would like to have multiple barrier inspection technology, you could go for acoustic or electromagnetic tool, because this will give you the corrosion profile for the first barrier, second barrier, third barrier. And some companies like GoWell or TGT, they have a very good electromagnetic corrosion tool that can give you the corrosion profile in the tubing, the 958 inch casing, 13-inch casing, up to the 30-inch casing. So they are available technologies in the market, can give you answers in one run without the need to pull out the casing or tubing. But if you need to see scale deposition, if you need to see an accurate corrosion, like a through holes with a direct measurement, I would still go for multi-finger caliper. Okay, so it depends on your objective actually. This is how you qualify which technology that you should go for. A lot of companies now are going for a combo package. So in UE, for example, ADNOC, they are doing a lot of combo packages like multi-finger caliper in a combination with electromagnetic corrosion tool. Some companies in Qatar, they are doing combination between video camera and multi-finger caliper. So the downhole video will give you a qualitative answers about what is happening downhole, and the multi-finger caliper will give you a quantitative analysis of the corrosion and the statistics of the metal loss. So it depends on the objective, but it's always good to combine two tools together. Second question, how come the internal temperature decrease with depth? Okay, so it's not decrease. Maybe the scale itself is is different, or I'm proposing here just one of the passes, because we are doing up and down passes, so the tool itself is just doing different passes.
Maybe
So
he's referring to the last. You see where you point the maximum well temperature. Below it,
Okay.
there is a back in temperature, like a drawback in temperature at the bottom of your plot.
Yes,
this
yes,
is
yes. Yeah. Sometimes it's maybe we have waited on some of the shallower interval, so the tool itself like is cooling down. So yes, if you are barking the tool in a shallower interval and then you continue, you can see an internal temperature decrease, because the internal temperature is not reflecting, or it's with a direct respect to the bottom hole temperature. That's the internal component of the tool, and this is the bottom hole temperature. But this is a good question. But I need to check the background of the sequence of events. I'm sure it's something related to the sequence of events when we were logging this well.
okay. Thank you. You can go ahead for the other slides. Yes.
Sure. Right. So this is the MFC data is presented as 2D data and variable density log. As we can see here, this track is variable density log. The data is non-centralized. That's in order to capture the key features. So the data has not been run through any centralization workflow in the same software, so we can pick the deformation that it is happening in this compilation. Just if you are not familiar with the processing of the multi-finger caliper, so there is one step when we are receiving the tool when we're receiving the data from the tool, we have to apply sensor offset, and then we have to correlate this data with the gamma ray open hole if we are having, or with the casing tally, and then we have to check each finger response, and then we apply centralization, and we apply eccentricity correction to make sure that the tool is in the center of the casing or the tubing that we are logging. So before we do these steps, there is important features or important events that we can see before we applying the centralization. So as we can see here in this case, for this vertical steam injector, we have 3.5-inch tubing. As you can see here, we have a 7-inch casing, and then we have 2 perforation intervals. Okay, and the perforation intervals from A till F, just I will tell you why on the next slides to define 2 important deformation events. So from A to F, we have a deformation, a helical buckling deformation. We will see in the next slides. And from perforation G to I, we have bend deformation, and I will tell you how we are defining this. But what I want to say from this slide, that before we centralize the multi-finger caliper data and push the data to the center of the tabular, this can tell us like if we are experiencing deformation in this casing or no. So we have a helical buckling across perfs from A to F, and bending deformation from G to I. So now we are applying the centralization. Okay, so as the logging is performed across the deformation and or buckling, the caliper tool is pushed off its central position, because there is a deformation in the casing. The amount of displacement away from the center of the well bore can be measured by the eccentricity. We can see that curve, that eccentricity. That means that the tool is in the center of the casing. So the amount of displacement away from the eccentricity, that's a correction we have to apply. Okay, and this is will tell us if there is ovalization of this casing, means that it's enlarged casing, and this happens a lot on the frac treatment. If you guys are doing frac treatment, so when you are applying frac on a very high pressure, so there is a difference between the thrust load and collapse load of the casing, and you can see a lot of deformation and mainly of ovalization or shearing or buckling of this casing. So some of the new practices, and I advise you to look at the GPT, Journal of Petroleum Technology, an entire article about running the multi-finger caliper before and after the frac to define the deformation that happens before because of the frac treatment. So all I want to capture from this slide is the term eccentricity. That's the amount required to displace the tool, or amount required to displace the multi-finger caliper tool from its centric position. So if imagine that you have something like that, okay, a vertical cylinder, okay, and you have the multi-finger caliper in the middle, okay, exactly in the middle. So there is no eccentricity correction to push the tool like right or left. So that means there is no deformation. But we will see in the next few slides that if you have the casing or tubing like this, okay, and you have the tool, for example, lying here. Okay, so the tool is not on the center. So we have to apply some correction to make the tool on the center. But after applying this correction, we will not be able to see this event. Okay, so this is the important of the processing for the well log analyst and the petrophysicist to apply the initial steps to define the well integrity issues before the centralization and after the centralization of the multi-finger caliper data. All right, so in this slide, this is much more likely related to the data processing. So those plots here are cross sections across the perforation intervals that I have mentioned from A to F. Just a quick reminder so you can follow. Okay, that's from A to F. Okay, when we are going down. So we can see here that when we are going down, as you are following the arrows, there is a displacement happening. Okay, so this top of perforation, it shows a direction of displacement of tool, and it pushed away from the centralized position of the well bore, and so provided the information on the deformation type. Since the deformation directional change across the top perforation depth from A to F. So let's imagine that this is the high side of the multi-finger caliper. Let's say that it's the one of the arms of the multi-finger caliper, and we can see it is moving. It is decentralized as we can go deeper. Okay, to imagine that on 3D, it will be something like this, but I'll leave that for a moment. Okay, so we have a direction of displacement that it rotate with the depth. So this is defined as a helical buckling. Okay, so this is again one of the important thing to have an experienced well log analyst to look at this data and to define the type of the deformation, and either it's buckling, bending deformation, ovalized casing, or sheared, and so on. So we can see here that we see the direction changing when we are going down. So with the 3D plots that's defined as a helical buckling. Helical buckling means that the downhole tubular string becomes a helix or spiraling around the vertical axis of the well bore. So try to imagine this in a 3D. Okay, that it's not only like a 2D dimension. Okay, it's not like a 2D dimension. It's there is also a 3D dimension like toward the screen. So this is a spiral or a helical deformation of this steam injector. The second type of the deformation, just to let you follow, now we will talk about the bending deformation. Okay, here from G to H. So here is the cross sections from G to H. Now you are going deeper. You are logging deeper, okay, or the data points is deeper. So the direction of this placement here is lateral, left to right pattern with a depth. Okay, so we have like something between like the left to right. Okay, it's not rotating in 360 degree as we saw here. So this is not a helical buckling. This is a bending deformation, as we can see here. So as the change here is directional between right or left, so this is suggest that it's a bending deformation, right? So yeah, it needs a very good analyst and petrophysicist to process this data and to capture the type of deformation. Luckily, there is a lot of good softwares in the market right now that can do this analysis for you. But still, you need an experienced petrophysicist or a well log analyst to capture those events from the multi-finger caliper data that you are deploying. And the challenge here, not only the integrity, it's also the temperature. Okay, so we are looking at deformed wells with the integrity issues, with the corrosion issues, that they are deformed, and also an extreme high temperature, high pressure condition. So I would like you to imagine if you have gas wells in your area, and you have never run a multi-finger caliber in them. They are being exposed to high temperature. They are being exposed to a workover and remedial treatment over the past 10 years, 20 years, or how old they are. And this will affect their integrity. So you need to run like a well integrity technology to define if those wells or those assets are in a good condition, or they need an attention. So this is part of the reservoir surveillance and reservoir management practice that the IOCs and NOCs are doing. I know it's a little bit confusing to differentiate between helical buckling, bending deformation. So I thought to get this self-explained diagram, you can check more information from Seafair Tech. That's their picture. So this is the well deformation mechanism, and the red dotted squares here, this is the difference between the bending deformation and the helical buckling. And you can see also a lot of deformation types like shear, like rust. We can see here rust that can be detected by a multi-finger caliber. Collapse, that's like the external pressure is higher than the internal pressure, right? So this is how can the multi-finger caliber can tell you more answers about the corrosion and the deformation in this high pressure, high temperature assets. My last slides, I'm taking 8 minutes more, sorry about that. So the HT/HB wells are challenging because of the depth, because of the availability of the sensors and upgraded tools requirement. Conventional ways of logging those wells are to cool them down. So they have to either you have to shut in the well to let it cool down, or you have to pump like a cool fluid, which both are time and cost consuming. So having high pressure, high temperature inspection tools, can save time. Can provide answers in assets that are high profile, and they are never been locked. So the heat shield, MFC, multi-finger caliber, proven data collection above 150 degrees C. The next challenge is to develop a slimmer tools that can operate in above 220 degrees C. Our target is to have tools rated up to 300 degrees C. Will provide additional feature, additional time downhole to log extreme temperature condition as the operators are drilling more deeper wells. As of today, we have reached to a huge or a very long laterals, a new 30,000 feet, and some wells I have seen them exploration wells, they can reach up to 18,000 feet, 6,000 meter or more as a TVD, which is a huge actually. So we require, or we need more high pressure, high temperature technologies to make sure that we are inspecting our downhole equipment and completion on a timely manner. So this slide just a background. If you'd like to check our website, we have a lot of ultra high temperature, high pressure tools that PLT. So we cannot also run only the multi-finger caliber, but we can also run a high pressure, high temperature logging in extreme temperature conditions. That's all. Yeah, if you'd like, if you have any questions after the call or now, you can scan the QR code. You will save my my email and my number to your contact list, and please feel free to drop me a line or send me a message anytime. That's it, Mr. Mazen.
Thank you, Mr. Samir. What is my screen? Yes. So thank you, Mr. Samir. It was a really informative lecture. Okay, I like this photo of the type of deformation. It was really good. And I hope our attendees get benefit from it. So if anybody have any question, he can jump in. If anyone have any inquiry. Okay, Ahmed said, thank you, Samir. Okay, so, okay, most welcome, Ahmed. Most welcome.
Thank you. Thank you, Ahmed.
Okay. Okay. So apparently we don't have too many questions. We get already a few questions during the webinar time. Anyone need the certificate? He just need to reply on our email that have been sent to us. We already sent the SPE paper that related to this webinar. You can share this presentation, Samir?
I think
okay.
I do.
If not,
I just need to
if not,
yeah. No, I think it's
no
fine.
problem.
I can share it, yeah.
No worries, because we'll share the SPE paper, okay, that have all the
All right.
details. Okay, and what's happened, we will put a link for this webinar on the YouTube, on Facebook, on LinkedIn, and we'll send it by email for all participants, so they can watch it again and again if they want to recap all this info. And just a very long heads up. I believe Scientific Drilling have a PLT tool as well. What other tool?
Yes, we are having the high pressure, high temperature production logging tools available on E-line or Slickline. It's even ultra high temperature rated. It's rated up to 600 degree F, and the tool itself is very slim. It's 1.44 OD, so you can deploy it in a drill stem test or drilling it on small restrictions. So this is one of the things that we are good at, like logging the high pressure, high temperature, not only for the oil and gas, but we do also for the geothermal as well.
Okay, so I believe next year our theme will be focused on production logging. We'll present like software, advanced production logging, special production logging, that the one that
Mhm.
you have, and for sure Scientific Director will be invited to present one of our webinar next year. Thank you again, Samir. If not sure if Jennifer is still here, if she want to something before we go. It's not here. Dr. Mohammed, you are still there? If we want to say something before we close. Okay, he texted me on chat on WhatsApp, but I believe he cannot hear me. So thanks for all our attendees. Thank you again, Samir, and see you everyone next month.
All
Dr.
right. Thank
Mohammed?
you very much.
Okay,
Yes.
thank you. You want to say something before we close,
Yes,
Doctor?
thank you, especially for Mr. Samir about his informative and distinguished lecture today. Thank you, everybody. Welcome to our SPWLA Iraq chapter. We will wait you another lecture and another time. Thank you very much. Thank you, Ms. Jennifer and Mr. Mazen.
Okay.
Thank you.
Thank you, Doctor. Thank you, Dr. Mohammed. Thanks for our attendees, and we'll be in touch next month. Goodbye.
Thank you. Bye.
Bye. Bye.
Goodbye. Have a good day.
Yes. Yes. Bye. Bye. I will close the meeting.